exciting webinar for you put together by Shuttle Lighting, and you can shop the Shuttle Lighting range through to the vast Voltex distribution network through our 58 branches nationwide, as well as our online store. There's Marthinus. Hello, how are you?
Good morning, Robin. Thank you very much. Good yourself.
Good, thank you. As I was just saying, lovely to see you all with us today. I'll hand over to Marthinus shortly, but just to let you know, there will be a replay link made available after the session for anyone who would like to watch it again. And we will be hosting a brief Q&A session after the presentation, so please do feel free to leave whatever questions you might have in the chat section, and we will address them afterwards. But that's it from my side, and over to you, Marthinus.
Good morning, Robin. Thank you very much. Yes, firstly, thank you very much for everybody for joining. It's a beautiful sunny morning here in Pretoria. I don't know where everybody are from, but I trust that everybody are still sort of under lockdown. But I'm thankful that we at least have great technology. Imagine if this happened 30 years ago and we had to use fax machines to communicate.
I can only imagine. But Murphy's Law, you'll hear the lawnmower or the weed eater coming on in the background. I need to invest in a pair of headset like yours. Are you ready to start?
Yes, I do. I just want to check that the videos are loaded as well. Yes, those are. Fantastic. Okay, thank you very much, Robin. Yes, we can start when you're ready.
Ready. Over to you.
Fantastic. Thank you very much. Good morning, everybody. It's Marthinus Smit from Shuttle Lighting. Thank you very much for joining our webinar. I hope that everybody will find benefit from it. The topic today is just the basics of dimming. We essentially concentrate on phase cut dimmers, the types that you do buy at Voltex, but we will give a bit of a insight into some of the difficulties that you do encounter with it, and etc. So, firstly, just for everybody's knowledge, Shuttle Lighting is based in Cape Town, where our head office is. That's also where manufacturing and packaging distribution happens. Tracy Stein, our marketing director, and Rich Smith, our CEO, they are stationed there and monitoring and moderating in the background. And then myself and Stuart van Torne, who's our national sales and customer relations manager, are based in Gauteng. Now, importantly, so just a background regarding us. Then we're going to look at the fundamentals of how a LED component itself dim. I think that's actually very important, and something which one overlook if you just look at a lamp, for instance. Not paying attention to the internal workings of it. Then we're going to look, as I said, at the normal leading and trading edge dimmers, and also the couple of the common problems that you encounter, how you solve that. Now, after that, we have a question and answer session, and afterwards, please stay on. Afterwards, we'll have two very short videos to show you a practical installation, which I'll elaborate a bit more in the presentation. So, firstly, regarding Shuttle Lighting, we are a 100% based South African company. All our designs, manufacturing, support, certification, everything occurs in South Africa. We also importantly, all our components, the hardware, everything are fully sourced in South Africa. We do not personally source anything from overseas. So our products do comply to the national regulator requirements for letters of authorities, which you must legally have in order to sell and or install a product. Now, we do export a bit to, we export to New Zealand and Australia as well. So our dimmers, the same ones that you purchase here in South Africa, have the full Australian New Zealand conformance compliance. We also export to Europe, and we have the CE and EU certifications and compliance and so on for the dimmers as well. Exactly the same ones that you buy in South Africa. Now, all those certifications and letter of authorities, everything is freely available on our website for download. Now, the important factor of being stationed in South Africa is that we provide immediate support, hands-on support immediately. If you require it, we're a phone call away, we're a WhatsApp away, solve the problem. We do go to sites wherever it's possible, and also importantly, because we do local design and manufacturing, we can very quickly adapt to any problem that there might be in the field, or new LED type or new driver type, and etc., and make those changes quickly. It's not a question of sending mail overseas and waiting 3 months for some result to come back and then it's not working. So just an overview quickly regarding our products, we are, as far as wholesale and distribution retail concerned, we are in the phase cut dimmer market. We do have some specialized lighting control products, but those are specified products, and it's not, and it's well, that's actually available on specific order for specific projects, and we often tailor to suit a specific project. So if we look on the top here, we have our classical bell press dimmer versions. Those are the 800 watt, 500 watt, 250 watt, and 125 watt dimmers. Now, those are all universal dimmers, which I'll touch on a bit later, but they are leading and trailing edge compatible, and they're setting for leading edge or settable for trailing edge. That is a specifier or installer specialized setting, but they also auto detect when to switch over from leading edge to trailing edge, for instance, or from trailing edge to leading edge, for instance. Now, importantly, the wiring, which I won't go into much detail here, that's all available on our website, but the wiring is very, very simple. There are two red wires coming out of the dimmers, and one red wire goes to live, the other one goes to load. You can't make a mistake. That's actually a standard which we started in, well, around about 2005, 2006, and it actually became sort of known as the SA standard, the two red wires, which we are very proud of. And then obviously we have the two white wires coming out of the bell press dimmer, and that simply connects to a bell press switch. The master zone controller, this item here on the left-hand side, on the right-hand side, this is a master zone controller. That is a very nifty device which we have, and it's a unique product. We up to now can't find anything similar in the world from any other supplier, and that allows you to connect multiple dimmers, bell press dimmers, together and operate it as if it's one big dimmer, but it also provides you simple Sine and zone control. Now, afterwards, we'll have a video to just demonstrate quickly how that operates and how the wiring operates. So if we look at our rotary dimmers, on the left-hand side here, we have our 800 watt and our 500 watt. Those are normal click off. If you turn the potentiometer right to the anti-clockwise, it clicks off. Those are classical trailing edge dimmers, but they're also universal. Then we have our new baby 225 watt dimmer, this purple one here. Now this is quite a unique product. This is quite a unique product because this dimmer, you press the switch, or you press the rotary part on off, just like your car audio system. So that actually provides you with a bell press interface into the dimmer. So you have your normal rotary way that you can turn the knob, but you can switch it on and off, and you can even dim from the bell press switch. It offers you the best of both worlds. Now, importantly, you'll see that there's a white wire coming out of this dimmer. There's an additional white wire coming out of it. Now, that white wire allows you to do full two-way switching and full two-way dimming with a rotary dimmer. That is a very unique product in South Africa, because for the first time, you can actually do two-way switching and two-way dimming with rotary dimmers. This dimmer is very slimline design, so it fits into all the S2000 type of switches, your Lears, Lagrange, your Osmos, all those kind of things as a standard universal fit. But also importantly, this small dimmer, this 225 watt rotary dimmer, can actually work with the master zone controller, and that's what we show in the video afterwards. So you can have master zone control for a rotary interface. Very unique. And then on the top, on the bottom right hand side, we have our DC dimmer. That is a low voltage dimmer that you use to dim your non-dimmable LED strip lights, which is also shown in a video afterwards. And importantly, this is the only product where you can actually safely dim a non-dimmable LED product. Any other place, you must use a dimmable LED, or dimmable driver. So in order to understand how dimming works, it's actually important to understand how a LED component actually work. So when I talk about the LED component, I'm talking about this yellow part here. That's the small part that actually gives out the light that you can see in your lamp, as I've highlighted here. Now we are used to a world of working on voltage. We grew up with 12-volt batteries and to 20 volt and etc. So everything worked off essentially worked off voltage. And in cases where we were hidden from the internal workings, such as with your fluorescent lamps, where it required a ballast, that was also fairly simple. You had a ballast, and there was no issue with that. So, but just to understand the LED part itself, your LED component, unlike your halogen incandescent lamps, which works off any voltage, LED component is a current-driven device. It works off current. Now that is a bit of an odd concept, and I think it's important just to understand that just a bit better. So inside your LED component itself is a very a complex mixture of various materials. It's yttrium and gallium and indium, and it's a very strange combination. Now any matter consists of, on a molecular scale, consists of particles. Now, if those particles are excited, they go into a higher energy state, which produces heat and etc. But very, very interesting. There's a quantum physics thing which happens inside the LED component materials, which as soon as those particles get excited enough, it actually converts into photons, and a photon is a piece of light, so it gives out light. But your excitement method there is current. So because a current is actually electrons moving down a conductor. So as soon as the electron interacts with the particle inside the LED lamp, or inside the material, it actually converts into photons. That's very similar to playing pool. If you have your white ball on the table and you hit it hard enough, enough current with your cue stick, your colored ball will actually jump off the table. And as soon as it jumps off the table, that's equivalent to converting it into a packet of light. So any LED component is thus fully dimmable, because if you hit it with a slightly smaller current, your photons don't get propelled, or you don't get so many photons. If you hit it harder, you get more photons. So there is an important difference between LED lighting or LED components and any other type of lighting. So if we look at the actual dimming of a LED component, obviously, as I said now, it's current controlled. So you always need a current to voltage, or voltage to current converter. You need a driver. Now, those drivers can be in various different formats. As you can see here, we can have a driver which is external. So this converts the voltage into the current. We have a driver built into your LED. This example here was actually an internal, that's inside a G10 lamp. Here's the external driver, which converts the voltage into a current. And then, for instance, in an LED strip light, we have a small voltage to current converter built into the LED lamp itself. So it depends whether your driver is dimmable or not. Now, if we look at the ways that the LED lamp that the driver can actually tell the LED component to dim, there are two popular methods. The one is the analog dimming. That is where the driver simply changes the amplitude or the height of the current. Now, that is a very simple method, a very effective and a cost-effective method, and that's a method which are used in the majority of your G10 lamps, your A60 lamps, and etc. It's a very simple method. There are advantages to it, but there are also disadvantages to it, which we'll not go into detail here. The second method is a digital method. Now, pardon me, this is most commonly known as pulse width modulation. There are other methods, but pulse width modulation is the most simplest one. Now, what happens in pulse width modulation is that you supply your LED component with a constant amplitude of current, as we can see here. Sorry, it's a bit difficult to draw there. And then you just turn it on for a certain period, and then you turn the component off. Now that on-off happens at anyway between 200 and 1,000 times a second. So you actually can't see that high frequency flicker. So if your off time is very large, you actually have, as you can see here with the dotted lines, you have a low average current into your LED component. You have low dimming, and as you increase the period of the on time and you decrease the period of the off time, that you have a much higher average current into your LED. You have, sorry, it's very difficult to draw on the screen. You have a much higher average current. Now, and obviously a higher light output. Now, this is a method which is used quite a lot in external drivers, for instance, and which provides you better accuracy. It has some disadvantages as well. So you do get some high-end dimmable drivers, which actually combines analog and digital dimming. You can always go into this afterwards or in a separate session if somebody's interested. So it all depends whether your driver is dimmable or not on your LED. Now, your driver's function is to convert some sort of signal from a dimmer based on what the user wants and convert that into a changing current. Now, if we look at the a number of different variants of dimmers which you can get on the market, you get low voltage dimmers like your 1 to 10, 0 to 10, Dolly, DMX, KNX, and etc. Those are all specifier and specialized products, and we don't go into detail on that. But if we look at phase cut dimmers, that's your normal dimmers as we've seen right in the beginning. Those are, from an installation point of view, from a simplicity point of view, and so on, are the most predominant in the market. There's an estimated there's an estimated 2 billion dimmers installed worldwide. Now, if we look at the phase cut dimmers, to understand how that works, if the voltage from the mains is a sine wave, and it goes up and down 50 times a second in South Africa, that's why it's called 50 hertz, or 60 times a second in America, that's why it's called 60 hertz. And the RMS, which is sort of like the average, is 220 volt or 230 volt. Now, there are a couple of different methods if you want to control that voltage now with your dimmer, to tell your dimmable driver that there's a change and it must change the LED intensity. So one method of doing that is if you, for instance, just cut off this top and bottom part of the waveform. Now, that is electronically exceptionally difficult, so that is never ever considered in the market. Another method is if we simply cut off some of the cycle, so you have some of the AC coming through, a full AC cycle coming through, full AC cycle coming through, full AC cycle coming through, and then nothing further. Now, this is a very, very simple method, and it works brilliantly, and it's called integral cycle control, but that's actually reserved for things like heating, underfloor heating, and heated towel rails, and etc., because integral cycle control will cause flickering in LED lamps. Now, another method is if you, very intuitively, if you just change the amplitude of the sine wave. Now, that is a very, very effective method, a brilliant method. It's called true sine wave dimming, but that is exceptionally expensive and very difficult. So your dimmer will probably cost you 25, 30 times the cost and 10 times the size, 20 times the size. Now, true sine wave dimming, that is reserved for very high-end lighting control systems in top-end theaters, etc. So the next best thing is if we simply, with the dimmer, turn off part of the AC cycle. So if we, for instance, on leading edge dimming here, if we initially, when the AC crosses through 0, do not let any voltage through to the driver, and then at a stage we let voltage through to the driver. That is called leading edge dimming, because your blank period where your driver don't get any voltage leads the period where your driver actually gets a voltage. Now, as one can anticipate here, you can see that your voltage will always have a sharp rise time. Now, that sharp rise time causes a sharp inrush current, and you have inrush current into your LED driver 100 times a second. That is typically what causes a lot of times incompatibility. It causes buzzing of your driver, of your lamp, and or of your dimmer. Also, because of your repetitive inrush current, you are very limited with the number of lamps per dimmer. So that's where trailing edge comes in. Now, leading edge, just going back, leading edge is also called triac dimming, and that is a popular method that was used many years, or has been used for many years, since the late 60s, up to now recently with LED lighting. But because of the disadvantages of the inrush currents and etc., trailing edge dimming was invented. Now, trailing edge dimming, initially, when the AC voltage crosses through 0, your lamp gets full, your driver gets full voltage, and then somewhere in the cycle, you just turn off. The dimmer just turns the voltage off to the driver. So your dead period, where your driver gets no voltage, trails your period where the driver gets voltage. So that's that's trailing edge dimming. Now, the advantage of trailing edge dimming, as you can see here, somewhere in the cycle, your voltage just turns off. So there's no inrush current generated. If there's no inrush current generated, you can have much more lamps on your dimmer. You have no noise, etc. So trailing edge dimming is much more complex electronically than leading edge dimming, but it provides tremendous advantages for LED lighting, and that's why the default for most LED dimmers is trailing edge, and trailing edge dimming is actually recommended by most LED suppliers worldwide. Now, importantly, there are some cases which I'll touch on later where you actually want to have a leading edge function as well. And so if you have a universal dimmer, it's actually trailing edge and leading edge and switchable between the two. So if we just start looking at practical problems which we encounter, and there are many, unfortunately. So the first problem that you encounter is the question which we get so many times: how many lamps can you put on your dimmer? You know, it makes sense that if you have a 5-watt LED, that you can place 100 5-watt LEDs on a 500-watt dimmer, but yet it, in the majority of cases, doesn't work. Now, I'll get into that a bit in the next couple of slides, why it doesn't work. But just as far as the actual recommendations, how many LEDs you can place on your dimmer, because of all the varying characteristics, the different driver types, the variances in designs, and etc., it's impossible for your LED supplier or your dimmer supplier to have a blanket to say that your whatever wattage dimmer can dim 20 lamps, because it's not always the case. So the recommendation from Europe is that you use your equivalent wattage of your LED. Now, on the majority of LEDs, you'll see that it's printed on the box. It says that your 5-watt LED has a replacement wattage. In this example that we've taken here, your replacement wattage is 70 watt. Now, that is not something which is just sucked out of somebody's thumb. There's a very careful set of measurements and equations according to the CE standard. So it's a careful science, essentially. So what the recommendation is that you take your equivalent wattage, the 70 watts here, and you use that as your dimmer rating. So in this example here, if we have 7 of those 5-watt LEDs, which equivalent wattage is 490 watt. So that is, you can only place 7 of those 5-watt LEDs on a 500-watt dimmer. That is the official recommendation. As soon as you have 8 LEDs, which is 560 watts, you actually overload your dimmer. Now, like I said, that is the official recommendations. And in the absence of any data from your LED supplier or your dimmer supplier, that is what you have to use. So because that is so limiting, Shuttle Lighting is very proud that we do compatibility testing on a heck of a lot of lamps. We've tested in excess of 100 brands. It's impossible to believe that there are more than 100 dimmable LED brands available, and in excess of 650 different LED models which we have tested. And so we have, as far as we can tell, the largest publicly available compatibility chart from any dimmer supplier in the world. So this is an example of what our sorry, I lost my train of thought here. I was just looking at the message here. So this is an example of what our compatibility chart looks like. You can see that we list LED brand, the specific model number, the rating, so that you're sure that it's the same product that we have tested. If we use an external driver, we actually state which driver we have used and its rating. Now, importantly, there are some LEDs, about 2% of the market, which are designed specifically for leading edge. So we actually test and tell you whether the LED lamp would like a leading edge or trailing edge dimming. And then importantly, let me just get my screen drawing thing on here. So importantly, then we list per dimmer rating or per dimmer wattage. Now that applies to our 500 watt, sorry, our rotary as well as our bell press dimmers. Exactly what is the minimum number of lamps and maximum number of lamps that you can place on a dimmer. Now, in this example here, as you see, we selected all the 5-watt LEDs, or not all of them, just a snapshot of 5-watt LEDs. And you can see here, for instance, on this LED here, you can place 9 of those. Now, these are according to careful measurements, and those measurements were verified by international bodies, the measurements and the methods. Now, on this 5-watt LED, you can only place 9 of them on a dimmer. That is very, very limiting, obviously. And that rule then of the CE recommendation of the equivalent wattage, that actually applies here. But then if we go up, we can see that the one above that is also 5-watt LED. There you can place 55 of them on a 500-watt dimmer. If you go up, for instance, on this LED here, you can place 70 of this 5-watt LED on a dimmer. So this is where the compatibility chart comes in, because if you simply work on the recommendations, you will not be able to have these quantities that we list here on the dimmers. Now, to understand where those differences come in, because as far as your client is concerned or the installer is concerned, a 5-watt LED is a 5-watt LED, and it is from the product data sheet and from the packaging, there's absolutely no indication why there's a difference between them. So that is why we do the compatibility testing. Now, this is one of my favorite slides of all time. It's called "Not All 5-watt LEDs Are Created Equal." So what we've done here is these are actual measurements. Now, if you don't understand the measurements, don't be intimidated by it. Simply look at the red waveform. The red waveform will always be the voltage across the lamp, and the yellow waveform will always be the current through the lamp. Now, on the bottom here, right hand bottom side, we plotted a 50-watt halogen lamp. Just as an example, you can see that the current, this yellow waveform, is a beautiful sine wave, 100% power factor, because the red and the yellow look exactly the same. But if we look on the top here, we can see that this LED 1. Now, this is a very, very typical waveform. You can see that the yellow waveform looks very similar in shape, or conceptually similar in shape to the halogen lamp, but you can see it's much lower. So intuitively, you can feel that you can place much more of this LED 1 on a dimmer than you can of the halogen lamp. You can see that the yellow waveform is much lower on LED 1. Now, LED 2 is a good example as well. That is also a very, very popular driver type. You can see that there's a portion here, I hope you can see that, a portion here where there's actually no current being drawn by the LED lamp, and then so your current is actually condensed into a smaller period here. So you can see that your currents are actually slightly higher than in LED 1. So you can intuitively feel that on LED 2, you cannot place as many LEDs on a dimmer as with LED 1. Now, LED 3 is also a popular one, and you can see here that the current is more condensed and a higher peak current. So here you can see that your peak current is that yellow waveform is nearly as high as on your 50-watt halogen lamp. So you can immediately just feel that of LED 3, you simply cannot place, let's say this 5-watt LED, you simply cannot place 100 of them on a 500-watt dimmer, because the current that LED draws, the instantaneous peak current, is nearly the same as a 50-watt halogen. Now, LED 4 and 5, those are also LED types which are available, sadly, in the market. And these ones, you can see that the yellow waveform is just, well, for lack of better words, just a complete random mess, because these LEDs do not comply to any of the CE standard or the ICASA standard for emissions. These currents, as soon as you have more than one LED per dimmer, these currents actually interfere with each other, and you get random flickering, and etc. And that is also why you are very, very limited with the number of LEDs on your dimmer. Now, importantly, if we just look at the previous slide again, the fact that there are so many varying number of LEDs per dimmer is not an indication of the quality of the LED. This LED, for instance, the quality is arguably just as good as the quality of that one, but it depends on the characteristics of how the driver is designed. So please do not use this chart as an indication of quality. That's certainly not the intention, and it's definitely not what is happening there. Now, so one of the biggest problems that face the dimmable LED market, for dimmers as well as for LED lamps, is that there's no international specification for dimmable LEDs and dimmer compatibility. There's absolutely none. So your LED supplier manufactures a driver or a LED lamp, and if it dims, he's happy, he dims and he sells that. Your dimmer supply exactly the same. He manufactures a dimmer. If he dims an LED, he's happy, but there's no specification to tell you that at your minimum intensity, that is what your light intensity must be, and your dimming curve and all those kind of things. So as we saw, as we've tested more than 100 different brands of LED suppliers, and that is the tip of the iceberg. So you can very well imagine that with so many different brands, And with a lack of clear specifications, it's impossible that you have the same dimming characteristics on all your LEDs. So your characteristics from lamp 1 to lamp 2 to lamp 3 differs significantly. Some dim lower, some don't dim so low, some flicker when they turn off, flicker when they dim, some turn off prematurely, and etc. Now, so for that reason, it's always important that your LED dimmer must be settable. Now, there are a couple of methods that people use. Firstly, there's a method which is widely used overseas, where you actually have a small screw turn pot in the dimmer enclosure, and you then use a small screwdriver and you adjust that turn pot to set your minimum intensity, for instance. Now, we don't like that method for the simple reason that firstly, it's an analog method. Secondly, those turn pots are normally so small that, with guys being tired and working in dark conditions and bad conditions, etc., in the field, it's very, very, very common and very simple to actually overturn those small potentiometers. You break them off, you strip them, etc. So it's not a practical thing. So Shuttle Lighting prefers to use a digital method. The digital method is done by a couple of keystrokes. The advantage of that is that it's completely non-intrusive. So for instance, if you did an installation in a hotel, for instance, and there's 300 rooms, and you have two-way switching and three-way switching, etc. So very often the dimmers are not at the switches. It's remotely installed in the ceiling somewhere, which very often happens in hotels, for instance. And your installation is signed off, and now the LEDs are installed, the lamps are installed, and suddenly you find out that there's some setting that needs to be done. Now your contractor must come in. You must open the wall switches, wall sockets. You must firstly find out where the dimmers are. You must open it. You must adjust each one. Then, in all probability, you have to prepare the paintwork and etc. on the faceplate, and so on. So that takes a lot of time. So the digital method which we use, which is also incidentally patented, is very, very simple. You set the settings from the switch. So that's actually very useful, even for remote assistance. So if we look at the first example, for instance, which is very, very common, sorry, where your LEDs don't dim down low enough. Now, there's once again, it's not an indication of the lamp quality if the lamp don't dim down low enough. It's simply purely due to the design, and we must keep in mind that there are no specifications to determine how far that lamp must actually dim down. We find very often that the lamps from European suppliers don't dim down as far, and I think that's partially due to the fact that in Europe they don't want to dim so low because it's normally cooler environments. In South Africa, you want to dim quite low because we have a lot of natural light coming in. Also importantly, the IC, which is also SFS specification or requirements for dimmers, IC 60669, there's a safety specification, it's an old historic safety specification for incandescent lamps, which says that at your dimmer factory default minimum intensity, there must still be a faint glow in your lamp. Now, that is because of incandescent lamps years ago. If there's, for instance, lamps on a dimmer and it's dimmed down low, and end user, replaces the lamp and he breaks that glass, then he has full access to the live part and he can actually shock. So you must be able to see that there's still a faint glow in the lamp as a visual indicator that your dimmer might still be on. So in the case of the LED not dimming down low enough, a very, very simple digital setting on the shuttle dimmers is, pardon me. So we have sorry, I lost my train of thought here. Sorry. So we have a default dimming range. That's obviously the factory default dimming range. And in the case where the LEDs don't dim down far enough, all you do, you simply press a button 9 times. The constant click, it's 1, 2, 3, 4, 9. The light will go to full intensity to show you that it accepted the setting. And now you can dim down to about 10% lower. That's electrical energy. Now, very often on LEDs, your electrical energy is not linear to your dimming or your light intensity. So that taking it down by 10% at low intensity will actually, in all probability, take your lamp down by a further 15, 20, even 25%. So that is actually very, very simple. A good example is just before lockdown, a lady who owns a guest house in George had shuttle dimmers installed, and she has 150 dimmable LED lamps. And it was literally signed off the day before lockdown. So the next day she walked through the guest house and tried the lamps, tried the dimmers and etc. And she found out that the dimming is simply not low enough. It's still quite bright. And she called the electrician or the contractor, and he said, sorry, it's lockdown. You literally can't come out. So she phoned us. It took me 10 minutes on the phone with her, and I did a virtual walk through the property with her and said to her, each switch, just go press a button 9 times. And does light do that? Yes, it does. Okay, just dim down, check, is it fine? And remotely, that problem was solved within a couple of seconds. The end user can do that because there's no need to open the switch. So a very common problem that we also encounter is where LEDs flicker when they dim down or at low intensity, or very common where LEDs turn off prematurely. Now, your filament LEDs, those are actually very common, that even at your dimmer, some of them, when your dimmer is at 50% intensity or 50% setting, your filament LED is already turned off. Now, with rotary dimming, it's not so much of a problem because the tendency is that the user will turn the knob until the lamp turns on. But with bell press dimming, it's quite a problem because as you dim down, the LED turns off prematurely. Now the user thinks that the dimmer is off, but the dimmer is actually on. So now it tries to turn the lamp on, and he presses the button, and he actually turns the dimmer off. So you get the call where the user says, I dim down, and then my dimmer turns off, and now I simply can't get it on. I have to fumble and battle, and then it turns on. Now, once again, that is a very common problem. So what you do is you set the minimum intensity to a user intensity. So you dim down to an intensity just before the lamp turns off or above where the flicker point occurs. And once again, very simply, from the bell press switch, you press a button 11 times. Now, with that new rotary dimmer, which I showed up front or initially, that setting is also done with the built-in bell press switch on the rotary interface. So you simply press a dim down to intensity where you want, press the button 11 times, and your minimum setting is saved. Now that setting is then saved in permanent memory. You can take the dimmer out, leave it covered without any power to it, install it a year later, and that setting will still be retained. It does not fade or change over time, where your pot method actually changes or can change as that small trim potentiometer that you set with a screwdriver as it gets dust in and temperature variations, etc. So digital method is modern and it works well. Then lastly, we do get an example where your LED lamps can actually flicker at a maximum intensity. That happens very, very rarely, but it can happen. But more commonly, typically there can be a lighting specification for the maximum intensity, especially, for instance, if you have accent lighting, let's say in a restaurant booth or in a restaurant where you have small booths and there's a lamp over each table. There you actually do not ever want your light to go above a certain intensity, and you want to prevent your manager, when he adjusts the lighting at certain times of the day, to accidentally make the light too bright, which immediately creates a bad effect. So very, very simply as well, you dim to a suitable maximum intensity which you want. Simply press a button 17 times and it's set. As simple as that. So what we've done now is we have very, very simply changed our default dimming range, where it initially was, as you can see here with the lighter, with the lighter lamps here. That was our default range. We've very simply set that digitally to the new range. Now, importantly as well, the shuttle dimmers are rather clever because what it does is it will actually automatically adapt its dimming range and its dimming curve to always be linear, irrespective of what you set that minimum maximum intensity. Because very often you do find that as soon as you set your minimum maximum intensity on another dimmers, that your dimming curve will be quite different. So you'll have quite a quick dimming in the beginning from maximum, and then reaching minimum, you have a very, very slow dimming. So we always make sure that it's linear dimming. You encounter a couple of other problems. Now, that is where universal dimmers come in, where universal dimming is important. So there are certain lamps, as we said earlier, which are designed for leading edge dimming. So it's important that your dimmer must be settable for leading edge dimming as well. If you use a universal dimmer, some of the universal dimmers that one do get overseas are not settable for leading edge, and it will only do some rudimentary or automatic detection, which doesn't always work. So also importantly for fault finding and field diagnostics, it's sometimes important to be able to set your dimmer to leading edge mode. We have examples where LED lamps were installed and the dimmer's factory default trailing edge, and the end client called us, as happened the other day in Houghton. The lamp that he used was a lamp from a Irish brand, very specialized lamp for Irish brand, but those are leading edge only. And so on trailing edge, they had all kinds of compatibility problems. And I simply said to the hi, are we still online? I've got a sorry, I just got a red banner that popped up, so I was just concerned about that. Okay, so in that case, we simply say to the contractor, do this, do that from the dial press switch, and the problem was solved in a couple of seconds. Now,
Marthinus, are you there? Sorry, I have some technical issues here with the connection. Can you hear me?
Robin, yes, I do hear you. I had a red banner which popped up on the bottom here. I do hear you.
I think it's resolved. I just had to refresh on my side. Sorry for that interruption. You can continue.
Okay, thank you. Yes, I see Melissa said that we are still online. Thank you very much. Okay, so now very often as well, people use retrofit. People do retrofit installations where you have old halogen wire bond transformer. Those heavy old transformers, and they just do retrofit with halogen low voltage. Now, inductive load, such as those transformers, will damage a trailing edge dimmer. Your trailing edge dimmer will go up in smoke in a couple of seconds. So there, it's very important that leading edge must be used. But because that is so, you have to quickly switch over from trailing edge to leading edge before your dimmer gets damaged. There you want auto sensing. So fortunately, the Shuttle dimmers has auto sensing. It's actually quite amazing. You can actually switch a wire transformer in on a trailing edge installation, and you can watch the waveforms, and it immediately switches over to leading edge. So there's nothing else that you have to do. It's very non-user intervention required. That's a fancy word. Okay, and then lastly, you have some conditions where you need specialized settings. I think a number of people are familiar with the problem that you use electronic transformer, like let's say the Osram mouse, for instance, or the other halogen electronic transformers, which has a certain minimum load. You now connect or you now wire LED lamps to that, MR16 low voltage lamps to it, and you encounter the problem that as soon as you start dimming down, you get flickering on your installation, or alternatively, you battle to turn your LED lamps on. Now, the reason for that is because of that minimum load. Now, we have in the Shuttle dimmers, we have two specialized settings. It's two hidden settings, which actually force the transformer to think that it has a minimum load conditions. And according to our practical testing, it's successful in nearly 100% of the cases. There's a couple of cases where it doesn't work, but in the majority of cases it is. So it's also quite magical. You get a call from the field. Contractor says he's got this and this electronic transformer installed, this and this lamp, and he has this problem. So okay, well, just press the button this many times, this sequence, and immediately, as by magic, the lamps turn on. So that's actually a very great benefit that we have in our dimmers. Now, very importantly, you do get the problem that, and I think it's important that one highlights this because it's actually quite a common problem. If you use an external driver, your LED lamp would, for instance, be specified for 700 milliamp and a voltage range of 8 to 12 volt. Now, your driver is in a 700 milliamp driver that's supplied with 8 to 12 volt output range. The problem now is, as soon as you start dimming, you start getting flickering, or your lamp doesn't turn on, etc. Now, the reason for that is that your LED lamp, your LED component, as it gets less current, the voltage across it drops as well. So we did an experiment with a 700 milliamp 8 to 12 volt lamp and found that at 10 milliamp, which is like a 5% light output, that voltage across the lamp was 7.2 volt. So your driver actually cannot supply sufficient voltage range for your LED lamp to work. So it's always a very good rule of thumb that if you use a driver, external driver for your dimmable lamps, specify your voltage range at least 10% lower and 10% higher, ideally, than your voltage range of your LED. So if your LED is 8 to 12 volt, rather use a driver that can push from 7 to 12 volt or 7 to 13 volt. This problem also occurs very often when you have a soft start in your demo, which any LED demo should actually have. We actually have another webinar, if anybody's interested afterwards, or in a separate session, where we explain dimmable drivers much more, and this phenomenon which I described here is actually highlighted. Now, lastly, I think we're going slightly over time, but lastly, just importantly as well, when you look at UPSs and inverters, you do get your quasi-sine or simulated sine wave inverters. Those should not be used for LEDs. I know people do use it, but it's actually not good. This example here, once again, is measured waveforms. The red waveform is the voltage out of the UPS, and it's you can see here, it's actually not a sine wave. So the word quasi-sine actually plays no role there. It's actually a block wave, and you can see here, this is 100 volt per division. So your peak, you've got a peak voltage on your lamp of 400 volt. Now, in this example, we use 10 8.5 watt LEDs, that's 85 watts of lamps, and you had a 2.6 amp peak current into your lamps. That is not good for your lamps. Your lamps won't last, but also the dimmer won't work properly on that. So I'm not going to go into details on the Quest factor, but in this example here, for instance, the same 8.5 watt LEDs, 10 of them, were used on a true sine wave inverter. So you can see on this waveform here, you can see the voltage output. That waveform looks exactly the same as from the mains. And you can see that the current is actually, the yellow waveform is actually nicely controlled. You can see this waveform here. However, when this installation, and this was a practical problem which we encountered in Cape Town on an installation on a 2.2 kVA UPS, on leading edge dimmers, immediately, because of the repeated inrush current, as you can see here, on this section here, you can see the red waveform, which correlates with what we explained right in the beginning on leading edge dimming. You can see that there was a 13 amp peak current going through the dimmer and through LEDs. Now, your UPS had to supply 13 amps. Now, that is a couple of kilowatts, which it had to supply to drive 85 watts of LEDs. Now, immediately when we placed that installation on a trailing edge dimmer, you can see that the current reduced to 300 milliamp. And you had no inrush currents. Your UPS, because in the previous example of the leading edge dimmer, the UPS would shut down the whole time because it sensed an overload condition. And on trailing edge dimming, it was perfect. So the message is actually that on LED lamps, UPS inverters, and so on, stay away from quasi-sine, simulated sine, etc. Rather use a true sine wave inverter. And if you do dim, pay attention to what type of dimmer you use. If you're unsure, contact us. We'd gladly do all the testing for you, and that's free of charge. That's a service which we always offer. So, in short, there's actually no simple solution because there are a lack of specifications. So it's important that your dimmer supplier can adapt very quickly, make changes very quickly if required. If there are new LED types, new dimmer types, new LED types and new driver types, and etc. Coming out. If you're uncertain, rather do a mock-up. I know it's sometimes very difficult, but we will gladly work with you and do that mock-up. Use our compatibility chart that is tested. We test each of those products in the lab. If the LED that you want to use is not on the chart, contact us. We get a sample or send us a sample. We do that testing free of charge for you and supply your LED back to you. That's our service to the market. Lastly, try and use LEDs which are good quality. Now that's obviously very difficult to determine, but rather not by, with all respect and no harm intended, but sorry, rather buy your LED lamps from Voltex, for instance, because they check their suppliers, they know that everything is fine. You know, don't go to the Chinese market and buy LED dimmable Q10 LED lamp for £5. It will give you problems. So I think that basically answers everything. As a summary, we have a quick questions and answers section, and then afterwards, please stay on the line. We have the 2 videos. It's short, it's 3 minutes and 1 minute, and I think it would be great that you just have a look at that. The videos will also be on our YouTube channel. So if you want to skip that now, you can, but rather watch it now. Thank you very much, Robin. Sorry, we went slightly over the time, but yeah.
Oh, thank you, Marthinus. It was absolutely such a wonderful presentation you put together for us and super informative. Thank you so much. I do see a couple of questions that have already come in. So I'm going to take you through them, and let me make you full screen here so everyone can, there we go. So the first question we got was from Raquina. She says, which dimmers are most commonly used in household LEDs, ones with digital or analog dimmers, sorry.
Which dimmers are okay in household? In most of the times you use a normal phase cut dimmer. Now your phase cut dimmer is per definition is actually an analog dimmer. The interface which we use to do the settings, that is digital interface, but the dimmer itself is analog. Your phase cut dimmer and your 1 to 10 volt dimmer, that's a low voltage dimmer, those are analog dimmers. Your only digital dimmers that you get are your dimmers like your Dolly, DMX, KNX, RNX, and then your various bus systems, your Crestrons and those kind of bus systems.
Thank you.
Answers the question.
I think that did. Thank you for that. A question here from Michelle. She says, well, compliments first, very well explained, thank you. And she says, is it possible to have too small of a load on a dimmer? Example, using dimmable LED globes on a small chandelier.
Ma'am, no, in generally not. If you use a trailing edge dimmer, our minimum load is about 1 watt resistive. So in the majority of cases, if you look at our compatibility chart, even our 800 watt dimmer, you can dim 1 LED with it. This example, give me a second. This example here is a LED candle lamp. It's from an overseas supplier. It's not available in South Africa, but we're testing for a client overseas. This is a 1.5 watt LED, and it's actually quite bright. And that single LED lamp actually dims perfectly on our 800 watt dimmer. In limited cases, you have a minimum load of, let's say, 2 or 3 lamps, but that is very limited.
Okay, thank you for that, and hello to you as well, Mish. A question here from Tracy saying, a question regarding the load pre-dimmer. Where do you find the halogen rating of an LED? Is it on the box?
Ma'am, yes, it's on the box. There are if you talk about the equivalent halogen rating, yes, because that is a CE requirement for Europe. You find that your lamps from Europe would have that printed on the box. It's not always printed on the boxes from on all the lamps, because the CE standard is not recognized in South Africa, and in South Africa there is no equivalent wattage that needs to be printed on the box. So it's not a legal requirement in South Africa. But certainly if anybody has an LED which is not on our chart, please send it to us free of charge. We do those testing and tell you exactly what is going on in there.
Fantastic, thank you. A question here as well, or a request to briefly explain the process of smart dimming.
The process of smart dimming.
I think, yeah.
I'm not quite sure what that question would entail, because it's actually such a broad definition. Obviously, on your smart dimming, you do get things like sensors and interfaces, where for instance you have a data hosting interface. that is reserved mostly for your 1 to 10 volt and your bus systems and so on. You have occupancy sensing. That is actually small dimming, where you can, if there's no movement after a while, you dim down. And then obviously you do get your connected dimmers, your IoT dimmers, and etc., which are also can be seen as small dimmers. That's actually a very broad question. I'm frankly not quite sure how to answer that properly. But certainly, pardon me?
I was going to say, well, to the person that asked that question, please feel free to email marketing@voltex.co.za. We can potentially look into that question for you and put you in touch with the relevant people. So
Great.
we can't all have the answers to everything. Another question here from Mario is, how does one check G10 LED quality?
How does one check G10 LED quality? Oh, G10 LED quality. That is actually a nearly impossible question to answer. Your quality of LED lamp determines on so many factors. Firstly, it depends on your driver design. How your driver, fundamentally, the waveforms, as we've seen, in that slide with the 5-watt LED is not created all equally. Those waveforms one can check very, very easily, and there are some of the LED suppliers which actually has oscilloscopes which they can check, which they do check their products before they purchase from overseas. We can certainly check it here, but that is only one small part of it. It depends on the quality of the components that are used inside your LED driver. If substandard parts are used, you won't know that. You will only see a failure after 3 months or 6 months, for instance, and there's actually no way without doing accelerated agent testing to determine that. Then it's also a factor of your thermal solution, whether your LED lamp is properly designed or designed to cool down properly and so on. So that is actually a nearly impossible question to answer. So like I said earlier, the advice is normally to stay away from, with, once again, if I may use, if you excuse me that I'm making an example of saying, buying a 5 rand LED from the Chinese market where you don't know where it comes from. Rather go to a trusted supplier. We know that from long-term relationships with all the LED suppliers to Voltex, for instance, their products are all good. In the majority of cases, they actually send lamps to us for compatibility testing, and we then do a couple of tests and so on. So we do know that the suppliers to Voltex are good quality and they comply to all the standards that there are.
Thank you for that, Marthinus. To Jürgen, thank you for your comments. They've definitely been noted on our side. And I'd just like to mention we have launched an offer for you to shop the Shuttle Lighting products on the Voltex online store. We have both a click and collect and online delivery. So please feel free to shop on Voltex store or go to one of your nearest Voltex branches. I'm going to go ahead and play those videos for you, Marthinus, but from my side, I just wanted to say a huge thank you for such a wonderful presentation, and thank you to everyone for joining us today. And please stay tuned to the Voltex social media pages, as well as our website for more webinars that we have over the next coming days and weeks.
Thank you much, Robin. I appreciate that.
And here we go.
In this video, we demonstrate the Shuttle DC dimmer. It's rated at 96 watt, operates from 9 to 48 volt, and is auto-sensing on the input. It's mainly used to dim low voltage strip lighting, 12 or 24 volt, but it's not limited to strip lighting only. It can work with some constant current LED drivers, but operation is not guaranteed and must be tested. Here we have a normal non-dimmable LED power supply. It has a 12 volt DC output, and that may as well be any 12 or 24 volt battery for RV and other mobile applications. The other side of the dimmer connects directly to the LED strip, and the black and white wire connects to a belt press switch. These belt press switches can once again be doubled up and extended into multiple switch installations. Operation is the same as the AC dimmers. So press a button, hold and dim up and down. You can see the cycling is very, very smooth dimming down to a very low intensity. We have the soft start, the soft turn off, all the features that we have in all our other dimmers, and the preset settings. 3 clicks, for instance, goes to maximum intensity, works with this dimmer as well. Here we have the combined bell press and rotary dimmer. We have two in a faceplate. Wiring is pretty straightforward. There's a red wire going to load, red wire going to live, and then obviously neutral going to the other side of the load. Dimming is accomplished by turning the rotary knob as you normally do with a rotary dimmer, or then pressing and holding as you do with a bell press dimmer. The preset settings are also available. 1, 2, 3, lamp goes to full intensity. 1, 2, lamp goes to 50% intensity, and 1, 2, 3, 4, lamp goes to minimum intensity. As you probably noticed in the previous slide, there's a white wire coming out of the dimmer as well, and this is optional. You connect a bell press switch to the white wire, and the other side of the bell press switch to live. This then provides the functionality that you can do two-way switching and two-way dimming. With this dimmer, you can obviously double up the switches and have multiple way switching. This provides true two-way switching and dimming, yet a primary rotary interface. Finally, we added the Shuttle Master Zone controller to this installation. The Master Zone controller has 4 white wires. Each wire connects to an individual dimmer, and that applies to any of the Shuttle bell press or combined bell press and rotary dimmer models. One can also connect different dimmer models to the same Master Zone controller if so required. In this example, we have only 2 dimmers installed, so we don't use the other 2 wires. Should we have more than 4 dimmers installed, one can easily daisy chain multiple Master Zone controllers. The red wire from Master Zone controller connects to a bell press switch. The other side of the bell press switch connects to live, and we can easily daisy chain multiple Master Zone switches as well if so required. Now, in the example of this 2-zone installation, by simply double clicking the master switch, the lamps are synchronized to 50% intensity. Now these 2 dimmers operate as if it's one large dimmer from this single master switch. You can dim it up and down, turn it on and off. All your programming settings and preset settings apply here. So if we press a button 3 times, the lights turn on to maximum intensity and I can control it. I still have individual zone control if so required, or in the case of this external bell press switch, I still have individual control of each zone, but I can easily synchronize it and control it as if it's one large zone. This gives you flexibility in an installation, like for instance in a TV room, in a conference room, and etc. But it furthermore provides you functionality which extends beyond zone control. If you, for instance, have a large installation where a single dimmer will simply not work and you can't get a large enough dimmer rating, you split the zone into, or you split the installation into different zones and install simply a master switch and control the whole installation as if it's one large dimmer.
Thanks again for that, Marius. Those video demos are just so valuable. From my side, just wanted to say thank you all again for joining us. Thank you to the Shuttle Lighting team, and please, everybody, stay safe, take care, and we'll see you for the next one.
Thank you much, Robin. Thank you much, Voltex. Really appreciate that, and have a fantastic day.